Alright, in this section we're going to talk about something called inverse and joint variation. We're also going to need to go back and hit something called direct variation, which was introduced quite a long time ago in the course and probably has been forgotten. So we're going to go back and hit that idea again as well. Direct variation says that two variables are such that one of them is some constant times the other one. So y is equal to k times x, where k is some constant. So if k was 2, then y would always be twice as big as x. Okay, that's what direct variation means, that I can take some constant, multiply it by x, and that'll give me what y is every time. Okay, so that y is always 2 times as big as x, or 3 times as big as x, or something like that. An inverse variation is a division variation, so that y is equal to k divided by x. Okay, so direct variation is a multiplication relationship. An inverse variation is a division relationship. So our first type of problem is to tell if these equations show direct, inverse, or it's possible that it could be neither one of them, because a lot of equations are not specifically a multiplication or a division relationship. To be able to tell that, we need to get our y alone. So first step is to solve for y. So on this first one, that's not a negative, it's just the way that PowerPoint does the bullet points. We're going to multiply both sides by 5 to cancel that denominator. So I get y is equal to 5x. Then is that direct, inverse, or neither? Direct. And direct is a multiplication relationship. So in this problem, y is always 5 times as big as whatever x is. In the second one, y is already alone. So does that follow a direct, inverse, or neither?
Neither.
Okay. Addition doesn't fall into either one of those special cases. Okay. We're looking for either a multiplication relationship or a division relationship. And this one's an addition. And the last one, I need to get y alone. I'm going to get y alone by undoing what's being done to it. So I'm going to divide both sides by x. So that gives me y is 4 divided by x. So is that direct, inverse, or neither? Inverse. Okay, it's a division relationship. Questions? Okay, go ahead and try this one. Okay, so for this one, for the first one, I want to get y alone. I'm going to do that by dividing both sides by x. And that gives me y is equal to 4.8 over x. So is that direct, inverse, or neither? Inverse. It's a division relationship. A constant divided by x. For the second one, I need to get y alone. I'm going to undo what's being done to it. So I'm going to multiply both sides by 1.5. So I get 1.5x is equal to y. Direct, inverse, or neither? Direct. It's a multiplication relationship. And for our last one here, to get y alone, I'm going to add 3 to both sides. So I get x plus 3 equals y. Direct, inverse, or neither? Okay. We're looking for a multiplication or division relationship, and this one's addition. So addition and subtraction aren't going to work for us. Okay. Yes?
Will we always have one of each?
No. Just happened to be. I have another question for you, a little bit of a tricky one here. Whoops. What do you think about y is equal to x over 3? Direct, inverse, or neither? Take note that I said this one's a little bit tricky, so be careful about your first guess.
No, x is on top.
Right. So for our inverse relationship, we need it to be y is equal to k over x. We need x on the bottom, and this one has x on the top. So it doesn't quite match the inverse format, even though it's a division question. So then the problem is, does it work as direct, or is it a neither?
It's direct.
Why?
Could you multiply
Because
by
you could
3?
minus, you could times by 3 on both sides and then minus x and then divide by y. So it'd be 3x equals y.
It wouldn't quite be 3x equals y, but you're on the right track. That we could rewrite this with a multiplication. What kind of multiplication would it be? Instead of divided by 3.
Times 3 over x.
We would multiply by 3 if we were trying to get x alone, but we really want y alone, and it's already alone. So what's the same thing as dividing by 3? Multiplying by
1 over 3.
1 over 3 is the same thing as dividing by 3. So writing x over 3 is the same thing as 1/3 times x. So this then is a direct relationship, even though it was originally written as a division problem, because dividing by 3 is the same thing as multiplying by 1/3. Okay, so be careful of that inverse. Make sure if you're going to state that it's inverse, that your variable x is in the denominator. If it's on the top, then it's actually a direct relationship because that's really a multiplication by a fraction. For our second type of problem today, the directions tell us that the variables vary inversely. So when it says that they vary inversely, that means they follow that inverse variation relationship, that y is equal to k over x. And it tells us that when y is 8, x is 3. So if y is 8, then x is 3, and I can plug them into that inverse variation relationship. And what we want to do is find out what is the constant that works for this particular problem then. So we want to solve for k. So I would do that by multiplying both sides by 3. So 24 is our constant for this equation. So part A says write an equation that relates x and y. An equation that relates x and y should have a few characteristics to it. Equation means it should have an equal sign. Relating x and y means it should have x and y in it. Not numbers, but it should have the letters x and y in it. So our equation would be that y is equal to 24, since we found out that's what k is, divided by x. Okay, so when you're asked for an equation that relates x and y, you need to make sure you got an equal sign in there. That's what makes it an equation. Relating x and y means x and y need to be there. Not numbers for them, but the variables x and y need to be there. And then we'll plug in the constant that we found worked out for the problem. The second part of the problem then says find y when x equals -4. So if this relationship holds, then I can plug in a -4 for x and find a value for y. Okay, so first we want to find out what is the constant that relates the two variables by plugging them into the inverse variation format. And that allows us to solve for k, or our constant. We want to write that as an equation with k in its spot, but x and y as variables. And then use that equation to solve for a new value. Questions? Okay, go ahead and try this example. We are told our variables x and y vary inversely. That means they follow the pattern of y equals k over x. Then we're given a specific value that y is 6 and x is 1.5. So to get k alone, I'm going to multiply both sides by 1.5. That gives me that 9 is my k value, but that's not an answer because the question asks us to write an equation relating x and y. So we need x and y in here. So we're going to have y is equal to 9 over x. And the second part says find y when x is equal to 4/3. You can plug this in the calculator if you do it carefully and make sure you put parentheses around 4/3. But this whole chapter is going to be about fractions. So remembering how to work with fractions might actually be a good idea here to work with numbers before we start throwing letters into our fractions. So how do I divide by 4/3?
Multiply by 3/4.
Multiply by 3/4. So I get 27/4 as my answer. And that is a fine place to leave it. You could turn that into a mixed number if you wanted 6 3/4, so you could make it into a decimal 6.75, but I would just as soon leave it here. Questions on this type of problem? Okay, joint variation means that our variables vary by more than one variable. So we're going to bring a z into the problem here, and we're going to say z is equal to k, our constant, times x and y. So we really have three variables here. K isn't a variable, k is a constant, but x, y, and z are all letters. Okay, all variable values that can take on different things. So joint variation means more than one variable involved in it. So we're going to start by writing equations, turning these words into symbols, okay? We'll start with whatever letter it gives us first, so y. When you see the word varies, that's going to be equals. Then we're going to look at the type of variation it is. Remember, direct is a multiplication, inverse is a division, and joint means we've got more than one letter being multiplied in there. So this one says directly, so that's a multiplication with and then whatever letter it tells us. X. You will have a K in every single problem. Okay? Direct is a multiplication relationship where a constant is multiplied by your variable. So next one, y varies, so y equals. Inversely, so that tells us it's going to be a division relationship, and when we have that, our constant's always on the top of that division with x. So that tells us what variable goes on the bottom. Z varies. So we start with z equals. Jointly, so that tells us it's a multiplication relationship with the letters of x and y. Those are our three general forms for variation. Okay, that's our general direct, our general inverse, and our general joint variation equations. But we don't have to do that. We can start changing them, and that's what these last two look at. We can combine types of variation, or we can do other things to our variables as well. So y varies, says y equals. Inversely tells us it's a division with the square of x. So not just the x, but the square of x. So how would we write that? X squared. Okay, a lot of students want to say square root of x in your problem there, but if it was the square root, it would actually say the words square root. It just says the word square, so that's what we want to do, it's just square.
Is this going to be like problems where we have to do this?
Uh-huh.
Okay.
Yep, there will be problems in your assignment where you have to take the words and turn them into symbols. So the last one, z varies, so z equals. Directly tells us a multiplication, so directly with y, so we're going to multiply with y, and inversely with, so we're going to divide with x. You only need one k per problem, no matter how many different types of variation are in there, or how many different variables are in there. 1k can cover it all. So this one we want directly, so we want a multiplication with the y, and inversely a division with the x. Okay. Questions? All right, go ahead and try this set. So the first one says y varies, so we start out y equals. Directly tells us a multiplication with x. Inversely tells us a division with the square of z, so z squared. Next one, y varies, so y equals. Inversely, so that tells us a division with the cube of x. The next one says z varies. Jointly, so it's going to be a multiplication by more than one thing. And my notes here, I'm missing part of it. I'm missing an x squared, but hopefully that's still in yours. So multiplying with x squared and y. And the last one, y varies, so y equals inversely, so that's a division, with x and z. So we're going to put both of those on the bottom, so they're both a divided by relationship. Questions on any of those? Last type of problem to look at today. In these, we're going to be doing the same thing that we did in our second type of problem, except in those we're working with inverse, and here we're going to work with joint. So it says z varies jointly with x and y. So our equations are going to be z equals kxy. Z varies jointly with x and y. And it gives us some values to plug in. Z is 2. X is negative 12 and y is 4. So we can use this information to find out what k is for this problem. So I can do my multiplication and get negative 48k and divide by that negative 48 to get that k is 1/24. But that's not an answer because it didn't tell us just to find k. It wants an equation that relates z with x and y. So we want an equation with z, x, and y. So z is equal to negative 1/24 x, y. And then it gives us a new set of numbers to plug in. Find z when x is negative 4 and y is 7. So we can put any constants we want over 1, and then when we multiply fractions, we multiply together all the tops. So that would be 28 over all the bottoms, 24. There's 2 negatives in there, so that double negative makes a positive. And then we would want to reduce this down. They both reduce down by 4 to leave 7 over 6. Okay, give answers as reduced fractions. Questions? Okay, one last example to try. Alright, so we're going to begin with our joint variation equation that z is equal to kxy. And plug in our given value. Z is 5, x is 1, and y is 1/3. So to solve this for k, I'm going to multiply both sides by 3. And that gives me 15 is equal to 1k, or 15 is just equal to k. So then our equation is that z is equal to 15xy. And then we want to plug in our given values for x and y. And I get negative 420.
So the second part adds on to the first.
Yes. Yeah, the two parts built from each other. Okay. Your assignment from tonight is from 9.1.